So now that we've got the basics of Java completable futures out of the way, it's time to start turning our attention to the really cool stuff. And we'll begin with the most obvious place to start, which are the factory methods. And of course, the reason that's the obvious place to start is because those are the things that actually initiate the asynchronous computations in the first place. So until you use a factory method of some kind, it's hard to get much useful out of the more advanced features of Java completable futures. So you're hopefully familiar with the concept of a factory method, which is one of those classic patterns from the Gang of Four book, the design patterns catalog, which hopefully you studied in other courses or could pick it up on the fly. So it's basically a way of creating something and shielding the creation of something from the use of that something. And so in this case, the thing that we're shielding is all the asynchronous stuff that's taking place under the hood. The computations that are created with these factory methods we're going to talk about may or may not return values. Ones that are the supplyAsync variants will return values. The ones that are the so-called runAsync variants will not return values. So therefore, supplyAsync can be used to perform two-way asynchronous calls via a supplier, where a supplier is one of those functional interfaces in Java that we've talked about before. So as you can see, there's a pair of methods, supplyAsync, that is going to be passed a supplier only, and then there's a second variant of supplyAsync that's passed a supplier and an executor. The one on top, the first one, will go ahead and essentially arrange to execute an asynchronous task in the common fork join pool, whereas the second one will arrange to execute a task in the pool of your choice, which is designated by executor. So both of them will run asynchronously. The first one will use the common fork join pool. The second will use whatever executor pool you give it, which could be the fork join pool, but why would you do that? Just use the no parameter version of supplyAsync. In both cases, both methods return a completable future that, when complete, will have the result of whatever the supplier computation dictated it to do. And the supplier, if you recall, is kind of a lazy binding way of saying, here is some work to do, and then deep in the bowels of the underlying thread pool, whichever one you happen to use, based on whichever one of these methods you call, the get method of the supplier will be invoked to perform the designated computation in the appropriate thread context. And so the caller of supplyAsync will immediately get back a completable future. The computation can run in the background, and then when the result is done, that completable future will be triggered. And we'll see what happens at that point when we look at completion stage methods. supplyAsync can have parameters passed to it, but not in the way you might expect. If you think about what is a supplier is a functional interface that has a get method that takes no parameters explicitly and returns a result of type T, whatever the parameterized type of that functional interface may be, of that supplier interface may be. So even though there's not specific explicit ways to pass parameters, you can still pass them, as I'm showing here from the example in folder EX8, where we're going to call supplyAsync, and we're passing in to the supplier lambda here, F1 and F2, which are strings that are defined outside the scope of this supplier lambda. And these parameters that are passed in this way, in this fashion, are known as effectively final objects or effectively final variables. And that's just a fancy way of saying that once they're assigned, they are not reassigned up to the point where they're used in the context of the lambda expression. And you can read more about what effectively final variables are here at this link. And if you have any questions, I'd be happy to talk about them. So this is a conventional canonical way of passing parameters to a supplier lambda that otherwise appears to take no parameters. supplyAsync returns a value. And you can see in this particular case what it's going to return is it's going to return a completable future to a big fraction. And the big fraction that we'll get back when it's done computing in the background will be the results of multiplying big fraction 1 by big fraction 2. So BF1 times BF2 takes place in some thread in the background, and the result will be delivered back through this completable future that's returned as a return result from the supplyAsync factory method. Okay, so that's supplyAsync. The main thing to remember, two-way asynchronous communication. You invoke an operation, the caller gets a completable future back, the computation runs in the background. When the computation is finished, the completable future that was returned to the caller will be triggered, and then the caller can obtain the result in a variety of ways. There's also another variant called runAsync, which enables one-way calls, one-way asynchronous calls via a runnable, as opposed to two-way asynchronous calls via a supplier. So you can see here, again, there's two methods. There's runAsync that just takes a runnable, and runAsync that takes a runnable and an executor. So of course, the first one on the top uses the common fork join pool, and the second one uses whatever executor is passed in. And in both cases, a completable future is returned. But in this case, there's no return value because it's a void. So void is the absence of return value. That's the way to think about it. So it's effectively a one-way call. But we can still synchronize on its completion. We just don't expect to get a result back from it. Again, you can pass parameters to runAsync exactly the same way we did before. So you can pass them in as effectively final variables like you see here. There is no return value. As you can see, we have a void with a capital V. So there's no return value expected here. And if you want something to happen, you need to use a side effect. So this is an example where we're not returning any value, but instead what we're doing is we're going to print the results of multiplying BF1 by BF2, and then it's going to be printed as a mixed string. So this is a particular operation, printing, which has a side effect, which means display this in the console or wherever the output's been directed. And even though there's no return value, we can still get a result out of this thing. Now, having said this, supplyAsync is very, very common. runAsync is very, very rare. You almost never use runAsync. It's almost always better to use supplyAsync because you're almost always wanting to get return values back. That's why you're using completable futures. And the reason for that is because they're wonderful, cool, powerful support for completion stages, which we will talk about in just a bit. So runAsync is kind of, it's interesting, but not that interesting. Regardless of whether you use supplyAsync or runAsync, the asynchronous functionality will ultimately run in a thread pool. And if you think about how that maps back to the reactive programming principles, that allows the programs to be more elastic because it can leverage a pool of worker threads, which of course themselves are mapped down to a bunch of cores on a multiprocessor, modern multiprocessor that has multi-cores. By default, the common fork join pool is used if you use supplyAsync or runAsync with no parameters except the supplier or the runnable. But if you choose to use the version that takes the executor, you can designate a thread pool of your choice, which could be one of the ones that comes out of the box, like fixed size thread pool or cache thread pool, or a non-common fork join pool, or you could make your own custom thread pools if that's what you wanted to do as well. So in that way, completable futures in general, and in specifically completable futures created using the factory methods, are more powerful and more customizable than the parallel streams model, which really requires you to use the common fork join pool or some fork join pool, but you can't use arbitrary thread pools with parallel streams for various reasons. So just one of the limitations you have to learn to live with Java parallel streams. In practice, not a big deal, by the way, but just worth noting. So that's the end of the quick overview of Java completable future factory methods.